say we have an arrangement like this, where this pulley is something like this. A bigger pulley and a smaller pulley fixed onto this, so that one rotates, the other also rotates. If we look from this side, this is the view like. A string has been wound, and over here the 10 kg mass is there. And onto this one, a string is wound like this, and over here we have 5 kg block. System is released from rest, and we have to find out with what velocity this is going to strike the ground. That is the question. So here, now the first thing is, which of the blocks will come down? Whether it is 10 kg or 5 kg. Now we are not simply talking about weights. It is about movements. If you look over here, that is about this. If we jam the, if we hold it the pulley like this, so the torque of this force, when this is not allowed to move, then it means the tension in this string is going to be 100 Newton. So 100 into 1, if you look over here, so the torque of this 100 Newton about O is going to be 100 into 1 in which direction? In this direction, anti-clockwise movements. And what is the torque of this 5 kg when it is fixed over here, that this is 50 Newton, tension will be 50 Newton. 50 into this distance from here to here is 4 meter. So it is 50 into 4. 50 into 4, that is 200 Newton meter in this direction. So obviously this is bigger torque as compared to this. As a result, this pulley will rotate in this direction. The equation for this is 50 minus T1 is equal to 5 into A1. Acceleration of this and acceleration of this is going to be different now. If we take A1 of this is same. If this is going with A2, so A2 of this will be in same direction, this one only. This whole pulley is going to have 1 alpha only, angular acceleration. So we can say A is equal to R alpha, we can use it, where A is the acceleration point which is situated at a distance R from the axis of rotation. So if we talk about A1, that is A1 is equal to 4 into alpha. And what is A2? This is point P is moving in a circle of radius 1 meter. So A2 is equal to 1 into alpha. So this implies alpha is equal to A1 by 4. This implies alpha is equal to A2 by 1. So it means A1 by 4 is equal to A2 by 1. It means A1 is equal to 4A2. This is the relationship we get. So for this, it is T2 minus 100 is equal to 10 into A2. We also know that is A1 is equal to 4A2. Also for this, now this is a linear, and this is a relationship we have already established it. And now for this pulley, net torque is equal to Y alpha, that is T1 into 4 minus T1 into 4 minus T2 into 1 is equal to I is given as 10 into alpha. Now alpha you can put it anything, that is 4A1 or A2, anything you can put it. Alpha you can put it as equal to A1 by 4 or alpha is equal to A2, anything you can put in these equations, and from here you can get the answer. Once the value of A1 is known, we are interested in finding the value of A1. Once the value of A1 is known, V square minus U square is equal to 2AS, and we can get the answer. Now otherwise, we can just fix this 5 kg point mass over here, 5 kg over here, and 10 kg we can fix over here. And directly now we can use net torque is equal to I into alpha. We can directly use. How we can use it? It is fixed over here. So net torque is 50 mg into 4 minus 100 into 1. That is net torque is equal to I of the whole system. That is 10 of pulley, 10 kilogram meter square of pulley, plus of this particle about this axis, that is mr square, 5 into 4 square, plus of this particle about this axis, that is 10 into 1 square into alpha. So over here this comes out to 200 minus 100, 100 is equal to 10 plus section 580 plus 10 into alpha. So alpha comes out to 1 radian per second square. A is equal to R alpha. If we talk about this one, so A1 is equal to R is 4, alpha is 1, that is 4 meter per second square. Of this block will be 4 meter per second square. So we can use V square minus U square is equal to 2 into acceleration 4 into S. I think it was 2 meter. So V comes out to be 4 meter per second. We get the answer directly. We can also do it on the basis of conservation of mechanical energy principle. Over there you have to be clear, that is, if this goes by some distance, this will not move up by the same distance, and that can be found by S is equal to R theta. You can find the relationship. What is the relationship of the displacements of these two blocks?